Hello learners, welcome to Education Online program. So in our previous lesson we learned about linear expansivity, where we try to find how these solids increase in length with a given temperature, increase in temperature. So today we shall be looking at the expansion of liquids. Expansion of liquids. With the expansion of liquids, we are going to be looking at how liquids behave when they are heated. So you'll see that liquids behave the same way as the solids, in such a way that they also expand. That means that they increase in volume. We do not say the liquids will increase in size, but then because liquids take the shape of the container they are in, they do not have the definite shape. So with the liquid, how do they expand? So you see that different liquids expand at different rates given the same temperature. Meaning that if we have given if we have like kerosene and water, we try to heat them at the same time with the same temperature, same increase in temperature, we shall find out that they two actually have got difference in the way they expand. We are going to see all that with some experiments. So we see that liquids expand actually more than the solids. Why do they do that? This is because of their nature. If you look at the kinetic nature of liquids, you'll find out that the molecules in liquids are actually loosely packed together. You have your liquid there, so you see that their particles, the molecules, are spaced. They have some spaces between them, unlike the solids. With a solid object, you see that these particles are compact. They squeeze themselves. You see that? So this difference here in the way the particles are arranged in solids and liquids makes the liquids to expand more than the solids. So how are we going to find out that? Let's look at this experiment. But with this experiment, we're just going to look at a specific liquid. This time we shall look at water. How will water expand when it is heated? So we shall see and look at the expansion of water. For us to see that, we are going to get a flask. So we shall have our flask. So this is the flask. So when we have our flask, what we are going to do is we shall fill this flask with some water. So we have our liquid in the flask here. So if we have the liquid, this one is a tube. We shall insert this tube in the liquid. So when you insert this deep inside the liquid, for it to be more clearer, your liquid should actually be colored. We can use the water should be colored water. You just put any other, because with colored water at least you will be seeing the the meniscus. But then if it is not colored, it's going to be hard for you to see the behavior in the tube. So you get and you cork your flask. So our corking is covering it here. So you see that this tube here is fixed through a small hole that is in the cork. If we have, so this tube should reach the liquid. So what you'll do is, we shall first measure the length at which this liquid rises into the tube. So if your liquid rose up to some point here in the tube, now this time round, we take some, try to heat the liquid. When we are heating this water, now we are applying fire. After applying this heat, you're going to see that the level of this liquid, of the water in the tube, is going to drop. So this water will drop. Instead of having it here as this level, it will drop probably to somewhere here. It will be a very slight drop. If you're not very keen enough, you will not observe that. So when it drops here after you apply the heat. What happens as you leave it on the fire? So you'll see that as you continue heating our tube there, this liquid here, the water, is going to rise, and the rise in the tube here is going to be above these two levels. It will go probably somewhere up here. This is because the liquid has expanded. So now, why is it that at first, when you started heating the liquid, the water, there was a drop in the liquid level? Does it mean that the liquid reduces in volume in the flask? No, it is not the case. But then, when you started heating, what was the first thing that received the heat? It was the flask. So the flask was the first thing to start absorbing the effect of this heat. So as it is observing the effect of the heat, the flask itself, it will expand. So it is going to expand, meaning it will increase in size. So what happens when it increases in size? That means that the liquid has to occupy more area than it occupied before. So that is why you see that this liquid the water is going to drop, the level will drop slightly backwards, because it has to occupy more space because of the expansion of this flask. But then when you continued heating, you see that the liquid level will rise this time. This is because as this expanded, the liquid will start receiving the heat after the flask. So when it starts absorbing the heat, that means that the molecules will be loosened, and water expands more than the flask, because the expansion is more. And then this time our flask is smaller than the amount we put here is not going to be like the amount that we are going to receive. That's why you see that there will be the increase in the tube. This is because this liquid expands more, and it is going to increase in volume, and the increase in volume is going to be occupied in a smaller area. So for it to occupy that small area, it will move upwards. So that's how you will see the expansion of water. So we say that liquids expand actually, they expand at different rates. How is that possible? Let's take a look at an example of, we shall have three liquids like water. Let us see how it will behave with kerosene. And then we can have some other, either you can put it, you can have mercury or you can have alcohol, as long as they are different liquids. Now there we have three different liquids. How shall we find the rate at which these ones expand? So we shall have it as our experiment. To investigate. Expansion of different liquids. So we shall use also a flask that we can easily heat. So if we have our flask like what we have here without the heat, so we shall have three different flasks, but let these flasks be of the same size. And then if they are of the same size, they should also have the same tubes. Let them be the same in diameter. So if we have like that, let us have a small drawing here. Assuming this is our first flask there. So we also have the second one. And the third, they're not looking the same, but then make sure they're actually the same. This is just a sketch drawing. So we have another flask here. So now there are three. We shall fill these flasks with these different liquids. So we shall have our water. We shall have the alcohol. We shall have our kerosene. So this, we shall also fit them just the same way we did the water. We need to have these tubes, because it is these tubes that is going to help us know at what level has this liquid risen or probably dropped in the flask. So when you have your three like that, keep them at the same temperature. The initial temperature should be the same. So when it is the same, now you can come and check the liquid level. So make sure the liquid levels are all the same in the tube here. So you need the same amount of kerosene, you need with the alcohol, and then the water, they should be of the same amount. So you see that if this level was here, this level also, and that. So after doing this, now warm your water. When you heat the water, pour it in a basin or a trough. So when you put this, come and take your flasks and fix them in the trough, all at the same time. So you try to observe what will happen. You will see that the rise in this in the liquid, in the tubes, they won't be the same, however much they were at the same level at first. So you'll see that this is our alcohol. So we have our kerosene, and then we have the water. So you see that water will rise to a level somewhere probably here, then kerosene will go, and then the alcohol will be higher there, meaning that these three, given the same temperature, they are going to expand at different rates. So meaning that they structure the way their molecules, they are not the same. The structures of these molecules actually not the same. So you find that for one is more squeezed a bit than this one of the alcohol. So when it is expanding, the alcohol will increase more faster in volume than the kerosene and the water. So you see that the expansion of liquid, it has got its application. So where do we apply this? So you see that it is applied in the thermometer. The thermometer needs a liquid that can sense any slight increase in temperature. So you see that instead of water in a thermometer, we use the alcohol. Why? Because this water expands in a rate that is a bit which is not normal. So you see that this one here responds to any change, any slight change in the temperature. So we also have the expansion in gases. How do gases behave? The gases too also do expand. So you see that gases also are made out of molecules. So but the molecules in gases, they are not as packed as the molecules in liquids. For the liquids, yeah, they might be having they might be spaced probably like this, but then gases are widely spaced. You can have one here, and then the molecules, you see, it is not the same as this. So you see that the gases expands more than the way the liquids expand. So you can try your experiment to see how gases expand at home, where you can use your hands. How do you use your hands? You just need a flask, and then you need a basin, or we can say any other trough. So you also need you need a narrow tube. So with that one, how would you use it? So let us see. With the gases, so if we have our flask here, we invert this flask. So we have our trough here with water. So we are having here as our liquid. This is filled up with liquid, and this is our so we have this one here is filled with dry. We can have it as dry air. The air which has no liquid, it has no moisture in it. So you'll see that when you rub your hands, when you first put it like that, what happens? You will see that there will be nothing happening here. But then rub your hands and then try to put it around the flask. So when you rub your hands and put it around the flask, you're going to see that there will be bubbles coming outside the water. You will observe these bubbles in the water that is in the basin. Why? They think the bubbles comes because you see that the hands you rubbed and put there has heat. Because when you're rubbing, we say there is friction, and you can even feel the heat. So putting it there makes this air in the flask to expand. So when it expands, it will try to escape because the space here is no longer enough for it. So it is going to escape in the water in form of the bubbles. But then now try to remove your hands. Removing your hands meaning that you're cooling the flask. So when you're cooling the flask, what will happen? You will see that there will be rise. Instead of seeing bubbles, the water is going to rise in the tube here. So why is it rising in the tube? The water will be rising there because the air that had first escaped in the liquid, in the water, has now contracted. So if it is contracting, meaning that this tube here has got now less air inside. So this less air will cause lower pressure in the tube. So if there is low pressure in the tube, remember that atmospheric pressure acts around every object that is on the surface of the earth. So there will be atmospheric pressure acting on the liquid. So it will be this atmospheric pressure now to force the liquid to rise into the tube, because of obviously you already pushed the air out. You saw it as the bubbles coming out. So this one, the rise is going to be caused by the reduction in the pressure that is in the tube, and then the atmospheric pressure, which is being greater than the pressure inside here. So you see that it also has got its application. Where do we apply the expansion of gases? We apply it in the hot air balloon, where you see that when you try to blow in the air, to blow in air in the balloon, what will happen? This balloon is going to reduce in, it is going to be lighter. That means that it is not reducing in mass. The mass will still be the same, but then it is just becoming less dense. So if it becomes less dense than the air, you find it that it is floating in space. So this is what we know about the expansion of liquid. We should know that liquids expand more than solids, because the particles, the molecules in liquids are actually more spaced than the particles in solids. So when you come to gases also expand more than the liquids, because of the nature of their particles that are further more spaced than the molecules in the liquid. So we see that we can apply expansion of air in hot air balloons. So we can also apply for liquid. If it is liquid, you can apply the expansion in liquid in thermometers, where you need to choose a specific liquid, a liquid that expands with any slight increase in temperature. So with this, we come to the end of our lesson. We shall learn more about gas laws in our next lesson. Thank you very much for attending. We shall meet next time.